Okay, now let's compare the two methods, CRTN versus CNOSSOS. And here you see a picture of a predictor showing both types of models, the CRTN at the left and the CNOSSOS at the right. And I'll also show you how I created this graph, the number of exposed people. But first, let's have a little closer look at the methods itself. So the CRTN method, of course, calculates the L10. However, there's a TRL backend correction method to convert an L10 to an LEQ. We need that method because CNOSSOS only calculates LEQ. So in order to compare them, I use the TRL backend correction, method 1. Then the CRTN has two vehicle categories, the light and the heavy vehicle categories, while CNOSSOS has 5 vehicle categories, light vehicles, light trucks, heavy trucks, light mopeds, motors, and quads. For flow types, CRTN has 2, hourly or 18-hour, while CNOSSOS has hourly values in the day, hourly values in the evening, and hourly values in the night. So hourly values per period. So it's a different definition. Road service types. CRTN supports 4 road service types, CNOSSOS 15. Road types, CRTN supports 2 road types, motorways and non-motorways. In CNOSSOS, you do not need to define the type of the road, it's not needed. Other road aspects for CRTN is texture depth, gradient, low traffic correction. CNOSSOS has studded tires, junction type, and slope. Slope is of course the same as gradient. And then the meteorological effect, CRTN assumes a moderate downwind situation, while in CNOSSOS you have to choose between favorable or homogeneous or a mix of the two. And also in CNOSSOS you can set the temperature. So there are already on this top level view several differences between the CRTN method and the CNOSSOS method. So I had to make a choice, and this is the choice I made. In CRTN I used the TRL backend correction method 1 to convert the L10 to LEQs. And in CNOSSOS, of course, there's only one option, LEQ. Then, to make a good comparison, I only used light vehicles. Then, of course, in CNOSSOS, only light vehicles. For the flow types, in CRTN, I used hourly flows, and in CNOSSOS, I only selected the day period. So I made a comparison for the day periods, the 12 hours in the day period, and also the 12 hourly values for the 12 hours that are in the day period. For the road service, I chose standard. For CNOSSOS, I chose reference. Road types in CRTN, I used both motorways and non-motorways, as it should be. And in CNOSSOS, I don't need to define it. So that's a good comparison anyway. For the other road aspects, I did not use any. No texture depth, no gradient, no low traffic correction. In CNOSSOS, I did not use any studded tires and also no junction types. Then the CRTN, of course, calculates moderate downwind. So in CNOSSOS, I selected 100% favorable. And as a temperature, I selected 10 degrees Celsius, just in order to make a reasonable comparison. So let me switch to predictor now. And let me show you how I did my comparison. First, I started with the CNOSSOS method because that's already in the demonstration project of predictor. So I started with the CNOSSOS method. Let me deselect my div areas. And if I zoom in, you see that in CNOSSOS, the properties, you see a hourly flow in the day period. So the QD, that's the hourly flow in the 12 hours of the day period. So every flow in the 12 hours is the same. You cannot differentiate within these hours. And of course, the speed. If you go to the model list of items, you can see an overview of all roads in the model. And here you see, if I scroll to the right, here you see both the speed and the traffic flow. If I click on the header, you see that the highest traffic flow is for this 2,939 vehicles per hour for a speed of 115. So this is obvious a motorway, and then it goes down to lower values, down to 322 for 50 kilometers an hour. What I did is I simply copied this table to Excel. So I clicked on copy full grid, put it in Excel, and here, and I pasted it over here. Ctrl V. Then I created a new model because I wanted to copy and paste all this information in a TRL, a CRTN TRL model. So I created a new model. I just do it over again and selected Lima CRTN TRL because Predictor supports the purely L10 implementation, a specific L10 implementation for New Zealand, and a TRL to convert it to LEQs. So I select the TRL, CRTN TRL, I open it, and I also open the CNOSSOS model, and then I tile them next to each other, Windows tile vertical. And here I see my CNOSSOS model, and here I see my empty TRL model, my CRTN TRL model. Now I simply select everything in this model, go to Edit, select all, right mouse click copy. I click on my empty model, my CRTN model, and I use my right mouse click paste. And I make a copy and paste of all information in my CNOSSOS model into my CRTN model. So all buildings, ground regions, roads are converted. However, the attributes are not converted, are not copied. Because if I open my road structure, I see the properties according to the CRTN, and I see that the traffic data is empty. There's no flow. And per default, the percentage of heavy vehicles is set on 10 and the speed is set on 70, so this is also not correct. So what I need to do is to change all roads to hourly values, traffic TRL method 1, and then set all percentage of heavy vehicles on 0, put the correct speeds in it, and put the correct hourly flows in it. And that can be easily done going to the list of items, roads, and also here again I copy and paste my full grid to the clipboard. I switch to Excel. I go to my sheet 2 because that's the TRL CRTN, and I paste it. I did it already in the first session this morning. And now I simply, in Excel, I can do everything. So in Excel I can simply copy and paste my hourly value and my speed to all 12 hours, because here you see all the 12 hours in my spreadsheet. So it takes a couple of minutes, setting the correct links between the two sheets, but that's how it's done. And then simply do a Control A and then copy it, and then go back to Predictor, and then go in Edit mode in this one, and then select the first one and say Paste, Control V. And then everything is pasted again back into Predictor. So that's how I basically did it, the conversion. Takes a couple of minutes, but then you're done. So the end result, I will open the end result, are these two models. I'll show you them next to each other. Tile vertically. So here's my CRTN model, and here's my CNOSSOS model. And I calculated the CRTN model. Of course, I set my calculation settings first. No, for instance, no low traffic correction, etc. So I made the calculation parameters correct. Then I calculate it, and my noise contours look like this in my CRTN model. And then, of course, I have to show my day period. I did the same for the CNOSSOS. I calculated it. It takes about 5 or 10 minutes. And I show my noise contours in the day period. And now I can use the view zoom synchronized and zoom into a specific part of my model in order to have a first glance and a first idea of the contours. Do they compare? Well, I was very much surprised that the contours look quite similar. And of course, you see differences a little further away from roads, and here, zoom in here, you see differences. So a little bit different. It goes like this, here it goes a little bit, but still overall, they look quite similar. So I was surprised already. And now, of course, I want to calculate the number of exposed people in order to compare really figures in number of people and number of dwellings. I did that by, let me just show my div areas. Yeah, I did that by importing a demographic file. So I imported a shape file, and let me go to my demonstration project because that's where the documents, predictor, where it is, yeah, predictor demonstration project. Because in the demonstration project there is analyst example data for the Woerden model. Woerden is a name of a Dutch town. So I use the zip code area file, and then I will convert it to div areas. Div areas are help items. They do not influence the calculation, but they are very powerful and easy to use. So for identification, I use the number of dwellings, and as a description, I use the number of people, because then I can show it as a label in my model. Say OK. Now it's imported. Now I'm going to show my div areas also. And here you see the div area. This is a div area, and the number of dwellings is 11 and number of people is 44. So here you see the 11 and the 14, and I've chosen in this case 11, the number of dwellings as a label. So what I did next, I used the result analyze contours, so I can analyze my noise contours and confront it with the same shapefile, with this demographic shapefile, my zip code area shapefile, and then select, for instance, number of dwellings. And then I say start. First, the analyze contours option shows you the number of square meters per 5 dB noise class, but I want to show the number of dwellings, so I say start. And this is the number of dwellings for my CRTL model. Then I copy it to the clipboard and I paste it in Excel. This is my CRTN, number of dwellings per 5 dB noise class. And now I do the same for the CNOSSOS model. I go to the results, analyze contours. I do the same, confront it with the same zip code area file. Select number of dwellings, say start. Copy it to the clipboard, and I paste it just for the moment here. And then I paste, this line over here and put it next to here. And this is, of course, my CNOSSOS. Oh, with my caps lock on. This is, of course, my CNOSSOS number of dwellings. And then in Excel, I simply select this table and insert a graph, recommended charge. Perfect. Okay. So now I see CRTN next to CNOSSOS in total number of dwellings per 5 dB noise classes. And you see that CRTN has a slightly higher number of dwellings. So CRTN calculates slightly higher noise levels compared to CNOSSOS. And this was my whole exercise that I wanted to do. So yeah, even though I've made much assumptions, or not assumption, but I made it more easier, only day period, only light vehicles, reference road surface, etc. But still, it is interesting to see that as a first indicative comparison for light vehicles, CRTN calculates higher noise levels. So, and that concludes my presentation almost. This is again, not again, but this shows you how the method 1 of TRL converts L10 to LEQ. It's L10 times 0.94 plus 0.77 in the day period. So this is also included in my whole comparison. So I was really surprised that it really, it compares. I did not expect it. So, and this is of course what I did. I opened the existing CNOSSOS model of the demonstration project in Predictor, then created a new CRTN model, copy and pasted all items from the CNOSSOS model into the CRTN model. I set all roads in the CRTN model to TRL method 1. Then I used Excel. I copy and pasted from the list of items to Excel, changed it over there, and copied it into the CRTN model. Then I set the calculation parameters correctly. and for both CRTN and CNOSSOS, and then I calculated both models. And then I used the results analyze contours option to confront the contours with a demographic population shapefile. Typo. Okay, so thank you for your attention, and I'm opening for